So let's move on our final topic about tempering a standard. So tempering a standard is as per EN 12150. So I'm sure you're going to have a practical sessions which we'll have. So I would like to touch upon few things about what is exact standard it says, and in terms of European standard EN 12150 for tempering process. Optical test for two types. One is bow test and zebra test. The bow test again is divided into the overall bow and local bow, while the zebra test divided into middle roller wave and end roller wave. By the nature of toughening process, it is difficult to obtain glass is absolutely flat. So such why, so the standard says is safeguard us. So it gives us some certain regulations, certain process how to conduct the test. If in case if a processes, how to determine this quality, what is basis. It's like a Bible. It's like a set of standards has been listed over there, how to test on what are the values to be used in terms of glass tempering process. So fragmentation test, which as you all know about it. So as per the EN 12150, so we have to take it like a 360 by 1100 at the center market, where 50 by 50 mm you have. Once you mark it and you break it, so those area have to calculate. If it is more than 40 particles, your tempering process is passed for architectural applications. And mechanical test like a soft back test, like a 5 kg of soft back can be lifted, like it's like a pendulum test which can fall from the distance of 250 centimeter, and you can drop it. If it is not break, will be passed on this. And quality test, optical quality test, like overall bow, local bow, overall bow, which you can see that is a flatness gauge which will be kept in the center or be a diagonal portions, where you can measure this overall bow. What is basically bend? Is there any bend on there? So local bow can be, can be tested with the feeler gauge or dial gauge, like a 0.5 mm per 100 mm is a local bow is allowed as per the EN 12150. And this is the bow test. This is the overall bow test as per the EN standard is 3 mm for 1 meter is allowed as per the EN 12150. And this is the roller feeler gauge which you can feel through. If you're not able to keep it straight, the flatness gauge, you can feeler gauge, or these two can help us identify the how much overall bow, local bow is there. And zebra test, this is the optical test which we'll conduct from the distance of 3 meter distance at the 30-degree angle, which you can see when the glass exit. So already the zebra board has been placed over on the tempering furnace. When the glass exit, you can see through this how much the reflections against the zebra lines. If it is completely distorted, you have to reject it. So you can see that the left hand side and the right hand side textures it's illuminated, which shows that the glass perfectly all right now, as good as there is no zebra line has been completely distorted. It is as good as similar line of zebra board. So this is the test for optical distortion which you can test at the time of tempering. Next is during the zebra, either you can test or you can do it at the lab scale as well. This is a roller wave. Basically this will help us to understand what is the peak and valley distance of the tempered glass. So what you have to do at the if you take such a big glass, for example, as per the standard 360 by 1100 mm, if you take it, we have to leave it 150 mm at the bottom and keep the apparatus and just drag it from this till 600 mm or 700 mm. Then thereby you'll have readings of peak and valley distances. Then you calculate how much, what is the peak and what is the valley. So you take average and you can calculate this. So that's your overall roller wave. Basically roller wave will be tested. Either you can do it on the lab scale or at the time of tempering you can do that. And this is the most widely used in the processing industry, which is called the glazing angle surface polarimeter, which will help us how much strain has been induced on the glass. So this is the stress pattern. Because the left hand side will be a manual which you have to dial it till that the line comes here, that's a horizontal line. So based on the dialing gauge, you'll have there will be a chart. So we have to look at it and what is coming like that in the left hand side. Whereas the right hand side, you'll have a more, this is a digital kind of this, where you can see that exactly without altering everything. You can see that there is a rim lines which will be seen through on this digital meter, which you can see that also. And this is, we have already, having said that, we already discussed about this fragmentation test. This test has been conducted on 360 by 1100 as a sample. From the center 13 mm distance, you have to keep it. The either sharp knife you can take or a kind of tool which you can be used for testing that, detect that one. So once you've done it, so you have to mark it how much it is coming. You have to measure that one with the stipulated marked blue point over there. And nominal thickness, for example, 4 to 12 mm, the 40 count is as per the EN 1250, which is acceptable. If it is 15 to 19 mm, will be 30 count will be acceptable as a architectural point of view. The relationship between surface compression and fragmentation. This table shows a relationship between surface compression and fragmentations. Like type 1, like a 94 megapascal, when you measure it through the strain gauge glazing surface polarimeter, if you measure the 94, that obviously there will be relation between the particle count also close to 45 to 50. If it is more than 100, 110, then your particle count also will be more than 100 to 125. So it is correlated with megapascal to particle count. So that's all about relation between surface compression and fragmentations.
Tempering tests, we basically focus on 4 parameters, that is the overall bow, the roller wave, the edge lift, the fragmentation. The fragmentation is with respect to destructive or non-destructive. Now let us elaborate every parameter in detail. If you see in the tempering department, our main intention is to keep the glass as flat as possible. So how we are going to, and the flatness is dependent as the glass is passing through heating process, it acquires undulations and we need to overcome. So in order to overcome, the glass will be having, we need to overcome 4 deformations like overall bow, roller wave, edge lift and the local distortion. If you see in the figure, this is the overall bow measurement. The test how I am going to execute is, I am going to take the glass on the longest side of the glass, I am going to keep on the wooden blocks, setting wooden blocks at quarter position, resting on the glass, and I will be taking a straight edge ruler and keeping along the glass surface, and with the help of a taper gauge I will be measuring the gap between the glass and the straight ruler. Generally, as per the standard, in a 1 meter glass 3 mm bend is allowed. So this is how I am going to check the deformation. If you see here, I am able to check the deformation, that is the point local distortion, the point where from one end of the edge to other end of the edge, I am measuring with the straight ruler, and I am measuring the gap between the glass and the straight ruler, and 1 mm as per the standard in a meter glass 3 mm bend is allowed. So this is how I am going to keep the glass on a vertical supporting system. Now we will be understanding the roller wave. If you see the roller wave, what do you mean by roller wave? As the glass is passing on the rollers, it will be acquiring undulations. So we need to see how we are measuring the roller wave. What we do is, if you see in the figure, the glass is moving on the rollers and it will acquire roller waves. Generally the roller waves will be in the form of a sinusoidal wave. So it will be having a peak and a valley. So we need to measure the peak and the valleys of the glass And if you see, the next is the edge lift. This is how the edge lift is going to get. Edge lift is nothing but the distortion what we get on the edges. You can see in the figure there is a curl or dip on the edges, which will be measuring by leaving 100 to 50 mm on the edges. Next you see the fragmentation procedure, fragmentation test. If you see the fragmentation test, what we do is we will be taking a 360 by 1100 sample, and by leaving the half inch we will be taking a center point, that is 500 mm. At 550 mm we will be taking a center point, and by leaving half inch from the edge we will be marking the glass. Punching tool we will be punching the glass. If you see, the glass will be, and we will be applying a protective film so that the glasses shall not scatter. And when we punch the glass, we will be leaving a 100 mm arc length, and we will be measuring, we will be even leaving 25 inch on all the four sides of the glass, and we will be seeing the particle counts. You can see the particles we will get in this pattern. As per the standard, if I am breaking a 6 mm glass, I should get a minimum of 40 particles when I am measuring in a 50 by 50 square plate. Along with that, now we need to understand the other method also, which is a non-destructive method.